Now we have our function transformations, and I kind of want to start off with shifting our quadratic function. So if you don't remember what that looked like, it was f of x is equal to x raised to the power 2 or x squared. So from here, I think this is going to be the easiest one to see because we could see it moving left and right, moving up and down. If we had a different function like a constant function, we won't be able to see it moving left and right. So for here, we'll start with our quadratic. And one of the first things that we could do is look at how we could transform our function. So first thing is we could have that multiplier. So a times, so I just did shift 8 for an asterisk, a times our function f of x. But our equation is going to be in the form of f of x minus h, and on the outside it's going to be plus k. So I'm going to create a slider for each of these and see what happens to our functions. So here a is equal to 1. Let's make h equals 0 and k equals 0, just so we could start off with our same function. So if a is equal to 1, h equals 0, we have 0 here. K equals 0, we have 0 on the outside too. So first thing that we could start off with is h. H is going to be affecting our input. So what does it do to our graph? So let's press play for h. And notice that it shifts our graph left and right. Let me kind of restrict this so that we could see it a little bit better. So from -5 to 5. And let's hit play. So it's moving our graph left to right. I did put this minus here on purpose. So it's always going to do the opposite of what we have on the inside. Because here we have x, we're subtracting some random value. We're trying to get back to normal. That's what brings our that negative here. So it's always opposite of what we have on the inside. So if we have h equaling -3.5, it's actually shifting our graph to the left. So negative, positive, positive, negative. It's shifting it to the left. It keeps the same sign if you keep this part negative. So h shifts our graph from left to right. Let's zero this out and see what happens to k. K, notice that that shifts our graph up and down. Let me restrict this just so we could see what's going on. So from -5 to 5. Let's press play. So notice that this shifts up and down. So kind of think of this as like an afterthought. All of this crazy transformation stuff happens over here. And after all of that happens, then we shift our graph either up or down at the very end. So that's why K is kind of out here on its own, doing its own thing. And after we do this, I'll summarize it by writing everything down so we have it in our notes. But from here, let's hit pause and let's zero this part out just so we could see what a does. So I did say a, save a for the very end because it does do something kind of crazy. So from here, let's press a. So for some functions, it does squeeze it inside. Actually, we could talk about negative versus positive first. So here we have positive numbers for a. Over here, we have negative numbers for a. See how it reflects about that x-axis. So we have that mirror image whenever we have that negative here. And now from here, now that we know that it's restricted when a is negative, let's see what happens with different values of a. So we'll say from 0 to 5. So from 0 to 5, what does it do? So whenever the numbers are big, well, not really big, but close, whenever the numbers are larger than normal, it's going to squeeze our graph. Notice that we're kind of squeezing from left to right. It kind of forces things to happen there. So we have that. And notice that here, whenever values are between 0 and 1, they're always going to be on the outside. So it's almost as if we're stretching these. So here, larger numbers, so numbers larger than 1 are going to have that vertical stretch. numbers between 0 and 1 are going to have that horizontal stretch. So now that we have all of this, let's go to our notebook and see what we end up with, just kind of summarizing everything that we learned here. So from here, we did mention something for H. H, if you remember, it shifts our graph from left to right. So this is our horizontal shift. So we would always say that it's going to be opposite of H. So opposite of whatever we have inside of those parentheses. So opposite of this. Next, we talked about K. We said that K is our vertical shift. So we're just taking whatever value K is and shifting it either up when it's positive or down when it's negative. So vertical shift moves it up and down. And now for A, we had a couple of different rules. So the first rule was the most obvious, which was a negative A is going to reflect about the x-axis. So when A is negative, we have a reflection about the x-axis. When A is larger than 1. So when we'll call it the absolute value of A, because just in case A is negative, then we don't want that to interfere. So when the absolute value of A is bigger than 1, we have a vertical stretch. So with that absolute value, so kind of looking at this, we had a vertical stretch where this stayed in place, but everything else shifted up, or you could even think of it being squeezed, like horizontal squeeze. And lastly, for A, we had whenever the absolute value was small, so between 0 and 1. So 0 less than the absolute value of A, less than 1. We had a horizontal stretch. So we grabbed these and kind of pulled them outward. So we had a horizontal stretch. And just to kind of group things together, these two are matched here. These two are matched here. And lastly, these two are matched here. And there's only one more thing I want to show you guys. Last thing I want to show you is that it doesn't matter what function we're looking at. Let's take a look at our, I don't know, square root function. So square root function of x. If we were to shift these left and right, it's still shifting the entire graph left and right. Let's zero this or make this equal to 1. Yeah, if A is 0, then we're just kind of getting rid of the entire function. So from here, it's still shifting the graph left and right. It's still shifting the graph up and down for K. And A is still doing the same thing. You just have to kind of think about it a little bit harder, because from here we have that, oh, we kind of restricted it. So let's do -5 to 5. So positive numbers are still going to have, or large positive numbers are still going to stretch the graph up. Numbers between 0 and 1 are still going to have that inside stretch. Negative numbers are still going to reflect about that x-axis. And that's it. It doesn't matter what function you have, it's still going to do the same thing for all of those values. I hope this helps. If you guys have any questions, please feel free to ask. Otherwise, bye.